Hello guys, let's find the value for this series right here, and I've kind of given a stupid hint, series, but it's not that stupid because I've highlighted E. Yes, our E. The E that is approximately 2.7182818 blah blah blah. It is irrational. So, we're going to have to somehow use E and the knowledge of series to solve this series right here. So, we'll first have to find the expansion of E. Now, you can do that on your own, the whole derivation, but I'll simply write it over here. It's 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial into so on. You can see the pattern. And why we're going to need this is, we'll just see the denominator. We have 1 factorial, 2 factorial, 3 factorial, and so on. So it will somehow relate to E. And I'm not going to rub it just yet. We're going to have to use the series, the knowledge of arithmetic series, geometry series, or even harmonic series, or even the sequence to solve for this. Now, the bottom part, 1 factorial, 2 factorial, 3 factorial, we cannot really do anything of it. But what about the top? We have 1, 1 plus 2, 1 plus 2 plus 3, and it will go on till infinity, right? So, generally in sequence, it's easy if we find the nth term, or the rth term, or just the general term. So now let's look at the first term. We have 1 by 1 factorial. Second term, 1 plus 2 by 2 factorial. Third term, 1 plus 2 plus 3 by 3 factorial. That means in the 10th term we'll have 1 plus 2 plus 3 plus 4 all the way to 10 by 10 factorial. So that means our Tn, that is our nth term, this will be equals to 1 plus 2 plus 3 plus blah 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 all the way to n by n factorial. Now this, what is the sum of the natural numbers up to n? Well, quickly you can just use the formula n by 2 to a plus n minus 1 d. Difference will obviously be 1, and from here a will also be 1. You'll get n plus 1 by 2 into n factorial. And why are we finding the general term is because here, any series is just the sum of the terms, right? It is just the sum of the first term, second term, third term, fourth term, all the way to the last term. Obviously here there's no last term, but you can just kind of flow with it. So we're going to have to simplify this somehow, because here we know that this series goes on till infinity, because there is no end term. I haven't put a last term. This goes till infinity, and when n is equals to infinity, you can see we're going to have a problem. We'll have infinity by infinity factorial, that is just infinity, which is an infinity by infinity case, indeterminate. We don't want that. So we're going to have to somehow simplify this, which is kind of easy. As you can see, we have n by n factorial, and this is a quick factorial fact. N minus 1 factorial is just n factorial by n, or simply n factorial is equals to n into n minus 1 factorial. So right here we have n factorial is equals to n into n minus 1 factorial. That means this n and that n will cancel, giving us n plus 1 by 2 n minus 1 factorial. Now we need to simplify further, because we have n in both numerator and denominator. And a simple way to do that is, we're going to somehow need to introduce n minus 1 in the numerator again. Well, we can just do that. It's just n minus 1, and don't forget our plus 1, but to not change anything, we have to add it by 2. Or just simply, if you subtracted 1, add 1, remaining term is plus 1, it'll still be plus 2 by 2 n minus 1 factorial. And now split the numerator. So you'll have n minus 1 by 2 n minus 1 factorial plus 2 by 2 n minus 1 factorial. Now nicely 2 and 2 cancels, and here we'll have this and that will cancel, giving 1 by 2 n minus 2 factorial, because this is just n minus 1 into n minus 2 factorial. N minus 1, n minus 1 cancels, plus 1 by n minus 1 factorial. So there we go. When n is infinity or approaches infinity, let's say, this will be nice because we'll just get 0, and that is what we want. We have simplified it to what we want. Now, as I talked about earlier, this series, I'll just write Sn, is just, let Sn write. Sn is just t1 plus t2 plus t3 plus blah 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 till t infinity. So what you're going to do is just find t1, t2, t3. t1 is just 1 by 2, 1 minus 2 factorial, plus 1 by 1 minus 1 factorial, plus t2 is 1 by 2, 2 minus 2 factorial, plus 1 by 2 minus 1 factorial, plus 1 by 2, 3 minus 2 factorial, plus 1 by 3 minus 1 factorial, and so on. So you can see we have 1 minus 2 factorial, which is a negative factorial. But just check out my last video and you can see the negative factorial is just 0 or infinity or negative infinity. Basically 1 by 2 into infinity or negative infinity doesn't matter, is just 0. This part is just 0, that part is just 1 by 0 factorial. So we're going to have 0 plus 1 by 0 factorial, plus over here we'll have 1 by 2 into 0 factorial plus 1 by 1 factorial, plus I haven't simplified it yet, you'll understand why later in just a few moments. And I'm going to write one more term because you can kind of see the pattern, plus blah blah blah. Or here. So we have 1 by 2 on all of these terms, so let's just take that common. 0, just skip that because that doesn't matter, adding 0, nothing. So first you'll have 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus dot dot dot, plus the remaining terms is 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus dot dot dot. And earlier I wrote the expansion of e right over here. So you can see this is just e. So all we have is half of e plus e, which is just 3 by 2e or 1.5e. That is it. We have found our value for this series right here. And if you have the factorial in the denominators, just remember e. Series e. C e. So from that, just use e, expansion of e, whenever you see factorial. And if you learn something new, please like and subscribe. Thank you.